Hello and welcome to this poster presentation. My name is Christian Göttel from University of Neuchâtel, and I will introduce generalized deduplication for energy-efficient IoT networks with Hermes. This work was done in collaboration with colleagues from Aarhus University and University of Neuchâtel. What is generalized deduplication? Generalized deduplication is a concept that was introduced by Rasmus Vestergaard at Aarhus University. The initial goal was to reduce the cloud storage cost. It does so by finding identical and similar data chunks, while applying a transformation function. This transformation function is typically an error-correcting code. In our case, we use Hamming codes. To the right-hand side, you can see a dataset that has been split into equal-sized data chunks. These chunks have similar shapes but different colors. Data deduplication can therefore not deduplicate these chunks. However, if we apply a transformation function, we can split the chunks into a set of bases and a set of deviations. The bases can be deduplicated, while the deviations encode the single bit that distinguishes the chunk from the bases. We have expanded on this idea and applied it to IoT networks. The result is Hermes. What does a Hermes network look like? So we distinguish between three types of nodes. Source nodes, which are IoT devices that gather data and inject it into the Hermes network. Sink nodes, which are servers that are located somewhere in the cloud and which collect this data. And any node in between a source and a sink node we refer to as an intermediate node. Nodes are not restricted to a single type, but we restrict them to a single transformation function. If a node is not doing any data processing, we will call it a basic node. Other nodes are data deduplication nodes and generalized deduplication nodes. We did a couple of benchmarks with our prototype implementation where we evaluated locally on a Raspberry Pi 4B its performance and also in a small-scale network deployment. You can see that for large data chunks, there is a significant energy overhead, which is due to a memory bottleneck in our prototype implementation. Generalized deduplication can achieve orders of magnitude better compression ratios than data deduplication. This is because generalized deduplication can map multiple chunks to a single basis, which data deduplication cannot do. Therefore, data deduplication converges towards sending raw IoT data. Finally, the throughput of data deduplication and generalized deduplication is comparable, despite generalized deduplication having an computational overhead. With that, I thank you for your attention, and I'm looking forward to answer your question during the breakout session.